So, happy Leif Erikson Day. Have y'all seen that SpongeBob episode? Yeah. You know what he says? No. No, it's actually today. So you have to ask your history teacher or the internet. Tomorrow. Yeah, he's kind of a Viking. So, let's do this warm-up. We need to write a parallel and a perpendicular equation. Now, y'all are so smart and you remember everything, so you're going to remind me for parallel. Okay. For parallel, we keep the slope the same, right? And the b, the y-intercept, has to change. Okay. So, what would I write? Y equals what? 1 over 3x. I can change the plus 2 to minus 2. I could change it to minus 3. I could change it to plus 5. It doesn't matter. There are many right answers, but there's one wrong answer. Actually, there's a couple wrong answers. Nonetheless, you just don't use plus 2 again. Okay? Something has to change, and it's the b. Okay? You can. Wait. Sorry. You have to change it for parallel. Parallel, that's the one change. Different y-intercept. But, right here, perpendicular. So my slope for the original equation, and if you haven't been here, you want to follow along so you know what we're doing. So, 1 over 3 is this slope, right? Perpendicular, we are going to change it in two ways. So, the 1 over 3 is positive, right? So we have to change the sign to negative and flip the fraction. So it's going to be what? So the new slope is going to be negative 1 over 3. So let's write that down in our new equation. What? Sorry, what? Oh, sorry. Negative 3 over 1. Thank you. Appreciate it. Okay, so that's our perpendicular slope. It's going to be y equals negative 3 over 1. Thank you. If you only do one change, like I was about to do, that would not be right. So 2 changes, sign and flip. X, and then the b can stay the same. So the original one we had was plus 2. We can write plus 2. If you change it, it's still legit. Okay, but you have to change 2 things about the slope. Sign, flip. Okay. Now on number 2, what do you notice about number 2? Yeah, what form is it in right now? Do you remember what this is called? We're just asking what's the form for number 2. So this is called standard form. Okay? And we're trying to get into what form? Slope-intercept form. Yes. Okay? So, how do we do that? So, I know you were saying it over here. What do we do first? Okay, good. The x has to move first. If you want y by itself, and we need y by itself, the x needs to go to the other side. So this is a positive 3x. We are going to subtract. So minus 3x, minus 3x. And if you've been here, you know that I like to remind myself that these don't actually combine. So I put what here? An arrow to remind myself. The negative 3x is going to go in front of the what? Sorry, what? Right. We're going to cancel those out. So the 3x minus 3x, goodbye. What do I bring down here? Okay, good. Negative 2y, don't forget the negative, equals, okay, yes, negative 3x plus 8. Does everyone see 8 and the minus 3x don't make 5? They're not 5x. Doesn't work like that. They're, okay. So yes, to get y by itself, we need to get rid of this coefficient. Always we divide. And we divide by the exact same thing, -2. Everything gets divided by -2. Okay. So yeah, the negative over negative is a positive, and then we're going to leave it as a fraction, okay? So again, you don't want a decimal. You need rise over run when we're graphing, okay? So 3 over 2, x, and then 8 divided by -2 is -4. You can think of it as adding a -4, but it's the same thing as saying -4. Okay. Now here's the deal. That was only to get the equation. That's like literally nothing that they asked for. We need parallel. So remind me, if you haven't been here, what do I do for parallel? Change M or B. The B. Good. The y-intercept, the -4. So let's do that. Y equals 3 over 2x. You can use +4, you can use +1, you can use whatever is not -4. Now for perpendicular, I'm going to write 3 over 2 is my original slope. And now here's the two changes, the minus, or the sign change and the flip. So it's going to become -2 over 3. Positive to negative, 3 over 2 flips to 2 over 3. So let's write that. Y equals -2 over 3x, and then you can use the original -4 if you want. You can use +1. It does not matter. Any number. Actually, it could just be any number. So for perpendicular. Yeah, as long as that slope has opposite reciprocal. Okay, real quick. 9th graders. So who's in 9th grade? Cool. If anybody is in 9th grade, okay, tomorrow is the PSAT, and there are no calculators provided. You have to bring your own. Just making sure. And everybody, can everybody tell me, why is PSAT important? What? What'd you say? Scholarships. Okay. So. Okay, can everybody listen, please? So I don't have to record myself being a mean teacher to y'all. Yo! Let's take it down a few notches. I need you to listen. PSAT is incredibly important for scholarships for everyone. I would not suggest not showing up because it's so important that you can get free money just by taking a test and doing your best on it. Okay? So please show up, do your best, and listen to Mr. G during class. That would be normal and awesome. Let's do this. We are going to do some notes now. So, you can go ahead and start writing that down. Okay, so inductive reasoning. Okay, let's focus, please. Let's focus, please. For inductive reasoning, it says the process of observing data, recognizing patterns, and making generalizations on those patterns. Inductive reasoning is something you use every day, whether you acknowledge it or not. So we wanted to put an example of this. So again, something where you recognize a pattern and you use that information. So, can anybody think of something that's inductive that they use? Sure. Okay, so when you do a warm-up, you use your journal. That's a pattern. It could be something really basic and obvious. It's fine. What about your phone? Use it when you need to do what? Okay, like if you hear a ding, you might, or whatever it is, you might think you have a message or a phone call or something. Okay, so what happens like every day? Something that you like expect every day. Okay. Almost every weekday, but waking up in the morning, okay, typically you've slept, hopefully, right? So you wake up, eating, okay, these things happen. So, like for example, fourth period of the day, you're not going to a random class period, you're coming to M201 for math, right? That doesn't change day by day, right? All right. So here's an example. You can use this one, you can use your own, but the sun rising every day so far, I can conclude tomorrow it'll rise again. Of course, that's relative. We're circling, whatever. So, but this is called the principle of induction, the assumption that the future will be like the past. Okay? We operate on that every day. We don't assume gravity is going to change directions or anything like that. Okay? So everyone's getting down 1 and 2. So on number 3, when you use inductive reasoning to make a generalization, like the sun is going to rise every morning, the generalization is called a conjecture. Okay? So in math, we have these conjectures. We have these things that we've noticed in mathematics based on observation, just like you do when you observe in real life. Okay? So for example, if you like sports, you use induction all the time because you are trying to find patterns and predict the way an offense or a defense is going to work. If you notice Mrs. Marrero's jersey, she's wearing a Drew Brees jersey, right? So he was using a ton of many years of inductive reasoning to pick apart the defense and make some touchdowns and break records. So yes, I do want y'all to write this blue part right here. This is our formula we're going to use today for this inductive reasoning. Yes, please write down the blue right here. Right here. Write this down. Because we're going to need that to find the nth term of patterns with a constant difference. Okay, so everyone's writing down the blue. Yes. Kind of. So, let's do example 1. Example 1 says to continue the pattern to fill in the chart below. And it says then find the function rule. Now, to find the function rule, you're going to need that stuff in blue. But first of all, you should be able to fill up to a point this table, right? So, you got 1, 5, and 9. what do you notice is happening for these values from 1 to 5 to 9? Okay, so the pattern, very basic, is adding 4 each time. Okay, so we can figure out the next ones. Okay, so it was plus 4 here, plus 4, what's 9 plus 4? 13. Okay, and then the next two, 17, 17, and 21. Okay, so yes, yeah, adding 4 each time. Now, careful, yeah. So for this formula, AN equals, I'm going to write it down here. And then it says A1 is the first term. So if I look at my value table, this is my first term. So I'm going to write 1. Okay, it's not always 1, but in this case it's 1. Plus, and then I need the difference, which is each change, which is this little part right here. So yeah, 4, and then I got to use parentheses and minus 1. Okay, do you see what I put where and why I put it there? Now that is how you find n, some number. So this is what we're going to write right here. 1 plus 4, n minus 1. Now this is going to help us get the 20th term. Again, you don't want to have to add 4 each time all the way up to 20, or some of y'all wouldn't mind, but what if I said 100? Okay, that would be a lot. I don't want you to have to keep counting by 4s. So all you got to do is plug 20 into this formula and be careful to use order of operations. So first of all, let's write it off to the side. 1 plus 4 parentheses. Instead of n, my number is 20 minus 1. So I'm replacing n with whatever the number is. Now, order of operations, what are they? Okay, PEMDAS. P in PEMDAS is parentheses. Inside the parentheses, I have to do that first. So 20 minus 1. First of all, what is that? Okay, 19, right? Okay, so 20 minus 1 is 19. You have to do that subtraction in the parentheses first, okay? Because that's the P, parentheses. E is for exponent, no exponents. M is for multiplying, which we do have, 4 times 19. So now this comes next. 4 times 19, and I know we don't have calculators because of the SAT, but you can use your phone today. But 4 times 19 is 76, I believe. And then your last step, 1 plus 76 is 77. Okay? So that's one way to do it, using that formula, AN equals A1 plus DN minus 1 in parentheses. Okay? At the bottom here is another way, using a similar method. Step 1, finding the common difference. Now we did that, right? The common difference was plus 4 each time. Okay? And that is going to be the coefficient of n. This is also known as the slope of the function. I just like plugging stuff in, so I use this formula up here. And it's not that different. The only difference is step 2, it says to work backwards to find the initial term. So I'll do that in green. If I went back to term 0, that would mean from 1, I would have to do what to get back 1? If I'm adding 4, what would this be? Okay, good. Subtracting 4 would be -3. So basically they're saying this is your B. Whoops. This is your B, and then this is your M. So you could write it as y equals 4x minus 3. And you could plug in 20 into that as well. X, right there. 80 minus 3 is also 77. Okay, but people mess up on going backwards, so I'm going to stick with using this formula. Okay, either way works. Okay, you don't have to go back. You can just use that straight formula. Okay, we're going to do 2 or 3. We're going to do a couple together on the back, and then I'm going to let you try some on your own. We're going to flip it over. Example 2, okay? It's going to be same stuff, a little bit different each time, but first thing, what do? Okay, we can find the difference. 3 down to 1 is what? Okay, everyone with me? So 3 down to 1 is minus 2. 1 down to negative 1 is also minus 2. What are these other blanks going to be? Okay, so minus 3, subtract 2 again. Minus 5, subtract 2 again. Minus 7. So you're able to continue a pattern, right? Adding or subtracting a number. So that's your change. What else do I need to know? Right, well, before we get to the formula, we identify the change and also the starting point. Okay, so it starts at term 1 at 3. Okay, so when we write our formula, it's going to be an equals, so which number do I write first? The starting point, which is 3. Very good. Now, you can put plus negative 2 if you want to. You can put minus 2. That's fine too. Either way. But the change, and then we always put n minus 1. This is going to go over here. 3 plus negative 2n minus 1. And then plugging in a 20. Yes. Right. So so 3 down to 1 is just going down 2. And 1 going down to negative 1 is going down 2. So we just keep going down 2. These numbers tell you what the pattern is going to be. Right. Down 2, down 2, down 2. So our out to the side here, 3 plus negative 2, 20 minus 1. What do I have to do first for order of operations? Not multiply. P, which we are going to subtract, in parentheses. Parentheses first, right? So please don't forget order. 20 minus 1 is 19. Negative 2 times 19 is negative 38. So 3 minus 38, negative 35. Okay. Let's do a practice. We'll do the first practice one together. I'll let you do the other ones. But again, the change from 1 up to 4 is what? Okay. Plus 3. And then I also need to know the starting point. So I got 1 with a change of 3. So it's going to be what? Parentheses and minus 1. Okay. And for this one, we're going to plug in 20. 1 plus 3, 20 minus 1. 1 plus 3 times 19. 3 times 19 is 50. Okay, 57. And 1 plus 57 is 58. Oh yeah, sorry, we did forget the boxes. Yeah, I want you to. Okay, see if you can try the next 3 on your own. If you finish those before we go over them, you can already start on the next part, which is the assignment. But we're going to go over these next 3 in a minute. I want you to get some practice on it.